Hello everyone, I am K.S.Rangasamy, Department of Electronics Engineering from K.S.Rangasamy College of Technology, Richangud. Today we are going to discuss an important physical design step in VLSI, which is called routing. The routing plays a crucial role in converting a logical circuit into a physically manufacturable chip. In this lecture, we will understand what routing is and why it is needed and what is the objective of routing and different types of routing and the steps involved in the routing. This is the overview of today's lecture. The first one is a VLSI design flow, and next we are going to discuss about what is routing, then the objective of routing. After that, we will see the types of routing and finally the routing operation stages. This structured approach will help you clearly understand how routing is performed in real chip design. The next one is the VLSI physical design flow. The routing is one of the most critical steps in physical design. Before routing, we already complete synthesizers, floor planning, placement, and also the clock tree synthesizers. At the placement stages, the cells are placed on the chip, but they are not physically connected yet. The routing is a step where actual metal wires are created to connect all the required pins. And next one is what is routing? Routing is the context of VLSI design, refers to the process of connecting various components such as gates, transistor, and other functional blocks on the chip by defining the path for electrical signals. These connections are made using the metal wires on the chip, ensuring that the signal can flow between different pins of the components to perform the intended functionality of the circuit. The next one is the objective of routing. The main objective of routing is to create the physical connection for all the logical needs. Let us understand this step by step. After placement, the pins are logically connected but not physically connected. The routing converts these logical connections into metal wires. While doing this, the routing must satisfy several objectives. The first one is the minimal total wire length, that is shorter wires reduce delay and also the power. The next one is the minimize number of wires. That means the wires increase the resistance and reliability issues. And the third one is meet time requirements. The critical signals must arrive on time. And the last one is the design rules. That means we need to follow the proper spacing, width, and also the metal wire constraints. So routing directly impact the performance, power, area, and also the manufacturability of the chip. And the next one is the types of routing. There are three main types of routing in VLSI design: power routing, clock routing, and then signal routing. So each type has a different purpose and is handled carefully by the tools. So, and the next one is the power routing. So the power routing is used to distribute VDD and VSS across the chip. It must ensure low resistance path, the uniform voltage distribution, and also the minimal IR drop and electromigrations. The power routing is usually done using the wired metal lines and grid structure to handle the high current. And the next one is the clock routing. The clock routing is performed after the clock tree synthesizers that is CTS. The clock signal must reach all the sequential elements with minimum skew and balanced delays and controlled insertion delays. The spatial routing techniques and shielding are used because the clock is most timing critical signals in the design. And the last one is the signal routing. So signal routing is a connects all the remaining logical signals in the design. This includes data path, control signals, enable and reset signals. The signal routing must avoid the congestion and meet timing and reduce the crosstalk. And next one is the routing operation stages. The routing is performed in multiple stages to handle complexity efficiently. The main stages are global routing, the track assignment, detailed routing, and search and repeat. Let us briefly understand one by one. The first one is a global routing. The global routing plans approximate path for each net. It does not create exact wires but decide which region the net will pass through, which metal layers will be used. This helps identify the congestion early and guides detailed routing. And the next one is the track assignment. So in track assignment, the routing tracks are reserved for each net. It ensures that enough routing resources are available before the final routing begins. So, and the next one is the detailed routing. It is the most important one. The detailed routing creates the exact geometry, wires and wires. It strictly follows design rule check, that is DRC, exact spacing and width rules. This stages produces a final manufacturable layout. So the last one is the search and repair. In this stage, the routing violations are fixed. This stage will resolve shorts and open circuit problem and DRC violations and the timing issues. This steps ensures the design in clean and sign-off is ready. To conclude, the routing is a critical step that transforms the placed design into a fully connected chip. It affects the performance and reliability. I hope all of you understand this topic. Thank you for your attention.